Diluting Solutions. And this is one of the more challenging lessons of the course. We'll actually be using some fairly sophisticated algebra. So here's the goal. We want to mix a 50% solution and sterile water to result in 100 milliliters of a 20% solution. So I think alcohol may be a good model for us to think of. So we have one solution that is half alcohol, 50% alcohol. We're going to mix it with water so that the result is 100 milliliters, but that 100 milliliters is 20% alcohol. So we need to sort of consider our variables. So what I need to find is how much 50% solution and how much sterile water is needed. So this is one of the sections where I really don't care for the strategy that is used in the textbook. We're going to try to use this with a more algebraic mindset. We're going to start with the amount of concentration. So we're going to look at 50% solution, which is half alcohol. Sterile water is 0% alcohol. Now, the amount of solution we have is what we're looking for. We want to know how much 50% solution I should use, how much sterile water I should use. We will call X the amount of 50% solution that we want to use. We will call Y the amount of sterile water that we'll use. But while we mix those together, you will see we'll have a total of 100 milliliters. So if I take my water and I take my 50% alcohol, my mixture is going to give me a total of 100. Now, this third column we'll call the amount of alcohol, or the amount of medication. But again, I think alcohol is the easiest thing for us to think about. 50% of the total of X of the mixture is alcohol, so half 0.5X or 0.50X is how much alcohol I would have in that first bucket. 0, sterile water, times Y milliliters. Well, I have 0 alcohol in that second bucket. But the total mixture is supposed to be what? The total mixture is supposed to be a 20% solution. So when I put this together, mix these things together, a 20% solution. So I have a 20% solution of 100 milliliters. So how much do I have in the combined mixture? 20% of 100. 20% of 100 milliliters would be 20 milliliters of alcohol. So again, this is our H2O. This is our original solution. And this third row is the mixture. But if we look at these things, we essentially have two equations for us to work with. What's the amount of solution that I have? X milliliters of original solution, Y milliliters of water, for a total of 100 milliliters of solution. So X plus Y equals 100. In this third column, I have 0.50X amount of alcohol in the first bucket. I have 0 milliliters of alcohol in the second bucket. But when I mix the two together, I need to have a total of 20 milliliters of alcohol. So we will say then 0.50X plus 0 equals 20. And now the 0, of course, is not terribly relevant. So we get 0.50X is 20. Solving this, we divide both sides by 0.5, And 20 divided by a half is 40. So what that means is I need to have 40 what? That was 40 of my original solution. That would be 40 milliliters of the 50% solution. And now I'm going to plug that 40 in the other equation. So x is going to be 40. And we will say 40 plus y equals 100. So y is 60. So our conclusion to make this mixture, I need 40 milliliters of 50% solution and 60 milliliters of sterile water to get a result of 100 milliliters of a 20% solution. Let's look at another example. How many milliliters of 1 to 100 potassium permanganate solution are needed to prepare 1,000 milliliters of 1 to 8,000 potassium permanganate solution. Into 8,000, looking at the textbook. So, again, we want to take a look at our concentration numbers. And then we're going to look at the amount of solution that we're going to have. And then our third column will be the amount of potassium permanganate. So how do we do this? We are looking for how many milliliters of 1 to 1,000 potassium permanganate are needed to prepare 1,000 milliliters of 1 to 8,000 potassium permanganate solution. So again, we are looking for how much of the 1 to 100 we need. So that's the first concentration. How much of that do I need? What am I mixing that with? I'm mixing that with sterile water. So again, my second thing that I'm mixing is sterile water, which should have no potassium permanganate, so its concentration should be 0. How much sterile water do I need? That's my variable y. So we put these things together. What do we want to have? The mixture is going to be 1 part in 8,000. Again, that's my concentration. 1 part in 8,000 in terms of the mixture. Now, how much do we want to have in the total mixture? The total mixture is supposed to be 1,000 milliliters. So I think if we put this together, we have the equations we need to solve this. So if I have x milliliters of solution, so this is in milliliters, 1 over 1,000, so that's 1 gram, 1 over 100, 1 gram per 100 milliliters, times x milliliters is going to give me 1 over 100x. And again, the units we would have here would be grams of what? Of potassium permanganate. Just to keep the units straight. 0 grams of potassium permanganate per 100 milliliters of sterile water times y. This is just going to give us 0. But now 1 over 8,000 times 1,000 is just 1 over 8. So we have two equations here that we're going to try to solve. The first one represents the amount of solution that we have. X plus y has to equal 1,000. The second equation, we have 1 over 100x plus 0 equals 1/8. Obviously, plus 0 is not going to add anything to our discussion. So 1 over 100x equals 1/8. To solve for x, let's multiply both sides by 100. What's that going to give us? X equals 100 divided by 8, which is 12.5. So what that means is I need 12.5 milliliters of my 1 to 100 solution. Now we also need to see how much H2O we need, so we're going to plug the 12.5 in here. So we're going to take 12.5 plus y equals 1,000, subtracting 12.5 from both sides. What's that going to give us? 1,000 minus 12.5 is 987.5. So to answer this question, we're going to say we need 12.5 milliliters of 1 to 100 potassium permanganate. And 987.5 milliliters of sterile water to result in 1,000 milliliters of a 1 to 8,000 potassium permanganate solution.